Good evening, everybody. Welcome to this Studium Generale lecture on climate resilience. My name is Jaap Jansen. I'm program maker at Studium Generale, and it's nice to have you all here in this room and also on the balcony. Thank you all for joining us. We are on a highway to climate hell with our foot still on the accelerator. That's the urgent and harsh way Secretary General Guterres addressed the climate crisis. What seemed to be something of the future is happening already right here and right now. And how bad is it, and how worse will it get? And how can we prepare for the impact of climate change and extreme weather events? And what parts of the world will be affected the most? With me tonight to address these questions is Maarten van Aalst, and I would like to thank you for coming to Maastricht. I know you are very busy because you have a new job, so I'm really very pleased and honored to have you here tonight. So thank you very much for your time. And Maarten van Aalst is Director General and Chief Science Officer at the KNMI, and that's the Royal Netherlands Meteorological Institute. He's Professor in Climate and Disaster Resilience at the University of Twente. He's coordinating lead author in the IPCC, the Intergovernmental Panel on Climate Change. Until recently, he was director of the International Red Cross and Red Crescent Climate Center. The lecture will take 1 hour probably. We will see how it goes, and we will have a Q&A of half an hour after the lecture. Maybe we can try, if you have some questions during the lecture, we can see how that goes, but preferably after the lecture. So please keep your questions, and we will end the session at 9:30. So I would like to have a very warm round of applause for Professor van Aalst. The floor is yours.
Thank you very much. And indeed, the comparisons of climate change already leading us to the inferno are all around us. Yesterday I was in a panel at the EGU in Vienna, hybrid, but most people were in Vienna, which was called "Are We Sleepwalking into the Inferno?" And I think that the summary conclusion of that discussion was that we no longer have the luxury to be sleepwalking because we're getting wake-up calls left and right. The question is, what do we do when we wake up? So I'll present some conclusions of various strands of my work, and I still put the Red Cross logo on here, given that I only joined the Royal Netherlands Meteorological Institute 2 months ago. So you'll be getting a glimpse of what I know about the Netherlands and what we're doing in KNMI to address these global questions. But you'll also get quite a couple of examples from my previous role, which was, as you mentioned, the director of the International Red Cross Red Crescent Climate Center, where I led a global reference team, essentially building that interface between climate science and humanitarian practice, as well as the interface between humanitarian practice and global climate diplomacy. So in terms of the Q&A, and I'll make sure to end my lecture relatively quickly so we have some time for discussion, which might be the most interesting. We could veer all the way from climate science to climate diplomacy in the United Nations Framework Convention on Climate Change, to the very practical questions of what individuals can do, both to reduce emissions, but also to adapt to the changes that are already coming our way. So the purpose of this lecture is to give you a sense of what we're seeing, both in practice in the Netherlands, globally, but also what the IPCC has just concluded in its so-called 6th assessment, and then to give you some perspectives on how we can either look at this as indeed being on a highway to hell, as Guterres called it, or whether there are still glimpses of hope and actually also some clear calls to action that we can decide to ignore, and then maybe we will eventually be on a highway to hell, or that we can take in a more positive spirit as an encouragement to do the right things, because we are in a very critical time on this issue. So let me first of all start with a very boring slide, answering your question of what to expect. We're already seeing, and we will get, even more extremes. So climate change was long thought as this environmental problem, the iconic image from the Greenpeaces of this world of a polar bear on a melting piece of ice somewhere far away in the pole and somewhere toward the end of the century, end of the 21st century, to be clear, because these images were already around in the 1990s. What we're facing now is actually a more volatile climate. So we're seeing more extremes and we're seeing limits being crossed more when the climate is already changing, but then some peak occurs on top of that, than just these gradual trends, including also the sea level rise that we originally were worried about in the Netherlands, before we started to realize it was going to be the runoff from the big rivers or the heat waves that we're already facing. Secondly, more surprises. And partly surprises from the extremes that are sometimes happening faster than we had expected, and I'll give you a few examples. Partly also due to compounding effects. So we've often thought about this problem in a very linear way. You run your climate models, you look at the statistics of the rainfall or the temperature or the wind speed, and you project downward from whatever is happening in the atmosphere to whatever might happen to ecosystems or to human systems. In practice, what we're seeing is different things adding up, and I'll give you some examples. Thirdly, we used to think about this problem as rising risks, hopefully avoided by reducing emissions in time, but if not, we would adapt, and that would be costly, so therefore we would want to avoid it. So for instance, there's a choice: how much greenhouse gases do we emit, how much temperature rise do we get, how much sea level rise do we get, and thus how much do we need to raise our dikes. That was the classical image of the engineers in Delft. But what we're seeing more and more is that there are limits to adaptation, and maybe not so much in how much we can raise our seawalls, but in many other aspects of systems. And the coral reefs, for instance, are a classical example. I'll give you some examples of that as well. And that's quite a wake-up call in terms of what the science is telling us. It's not just a question of how costly is this going to get. It's a question of limits to adaptation. There are damages, problems we cannot avoid. And finally, the issue of responses to the problems that we're creating that are themselves becoming drivers of risk. And I'll give you some examples of that as well. But it calls for system thinking in our solutions. So as I was already discussing, these fallacies of a too linear interpretation from the atmosphere to the problems we face, we've also had too linear an interpretation of the solutions that we can implement. And we're seeing that some of the solutions we're now starting to implement are themselves becoming problems. And I'll give you some examples of that as well. So that's what to expect. Thus, how do we prepare? And I'll try to be explicit in a couple of the examples of what we can do. And here's, this is not coming out very well in the slides on the side, but I think in the back it's actually quite okay. This was a slide I still use in my presentations right now, even though it's clearly a Red Cross example. This was the Red Cross explaining why we were even at this climate negotiation, the United Nations Framework Convention on Climate Change, as they were meeting in Paris in 2015. To negotiate the famous Paris Agreement that in the end concluded successfully, those negotiations in Paris in 2015. And there was a lot of question, why is the Red Cross in this field at all? You know, why is the Red Cross worrying about climate change? Are you a new Greenpeace that's going to tell us to stop using coal-fired power plants? And of course, this was starting to become a humanitarian reality. And we were also worried about potential humanitarian problems in the future. So the French Red Cross created this poster as a graphic artist impression, a funny way to in a way explain why we were at that climate negotiation. And it says, it says in French something like, we'll always be there to save you if needed, but let's please prevent that from being necessary. Of course, in that way, sending a signal to negotiators, we're here to tell you this is becoming a serious humanitarian concern, and we count on you to set up a Paris Agreement that will keep emissions down so that we don't face the much more extreme rainfall that might cause flooding in Paris, Secondly, to ensure that collectively we adapt to what's already changing, and therefore, again, we prevent, if the rain becomes more extreme, that from resulting in flooding. And then, if really needed, we want to know what's going on so we can have our life raft ready to save people, if it would come to that. But let's please prevent that from being necessary. And of course, this was a graphic artist who created this picture of floods in Paris. And the story was won as a compliment to the iconic polar bear on a melting piece of ice at the end of the century. And people were joking about it while we were having that conference in Paris. It's a nice illustration of what the Red Cross would like to prevent. Well, you already got the hint just now. This was Paris 6 months later. So there were life rafts in the street of Paris already. No one died, but it was the flooding that we had been thinking about as the future we were going to avoid many decades on. We did the math on this particular example. Actually, Kane and I was already involved, my team in the Red Cross was involved in a new field of climate science called extreme weather attribution. And essentially what it does is doing the statistics both in the observational record and using climate models with and without the increase in greenhouse gases to try and figure out what role the already ongoing climate change plays in individual extreme events that happen right now. 20 years ago, scientists would not have given you the answer to that question. They would have said, that's too difficult a scientific question to answer. By now, we have the statistical tools to be able to figure this out for an individual event. For this one, it turned out the best guess is that it's about 40% more likely in the climate of today than it would have been without the greenhouse gases that we've emitted since the Industrial Revolution. That we would have this amount of rainfall in the catchment areas of the rivers running into Paris. So 40% more likely, significant, but also not a game-changing change in frequency. We've seen other events where the changes in frequency are much higher, by the way. But in this case, climate change did play a role. But did you notice anything else? Anything special about this slide here? They don't have it in the same way as we do, and you're close to an answer to this question, because there are big reservoirs upstream from Paris where they can store water, a bit like in our uiterwaarden. And if we get too big a peak, we essentially take more space and we store the peak for a while so that it's less extreme in the places where we care about not getting flooding. And those big reservoirs upstream from Paris would have dealt with this amount of rainwater easily if it had fallen in the beginning of April, when the reservoirs are kept empty to deal with lots of rainwater, meltwater coming from the Alps and the heavy precipitation during spring storms. But in June, Paris is not expecting meltwater. Paris is not expecting heavy rainfall like they got in June this time. Paris is preparing for a dry, hot summer. An ever drier and hotter summer in a changing climate. So in June, those same reservoirs are not empty to cope with the excess water. They're filled to the max to ensure Paris has enough water during the summer. So this is one of those examples where I mentioned that we are maybe preparing for one type of extreme, rightfully so, because it is getting hotter and drier in summer in Paris. But the way we've prepared reduces our options to deal with the other extreme, in this case the extreme rainfall. And it's those combinations of effects that are creating much bigger risks than we had anticipated in the past. And again, that linear approach of thinking about one problem at a time, in one unidirectional way, both in terms of how the problem emerges, but also how our solutions are solutions or not, is not working. And then that brings me to this quote. We're in an academic environment, studium generale, so I thought I should throw in a little bit of Greek. But I'll give it to you in English. It's in the very nature of probability that improbable things will happen. Beautiful quote by Aristotle. But then the side remark is that maybe some improbable things that happen are not very improbable in the first place. And of course, this is Aristotle's warning about probability density functions in general. There are tail ends to distributions. And I mean, our classical example would be forecasts, right? If a forecast is 90% right, you're expecting to get it wrong once every 10 times. You must be wrong once in a while. So that's in the nature of probability. Now, of course, what we're dealing with climate change is loaded dice. We're no longer facing the same probability density functions, the same ways of expecting things, improbable things to happen once in a while. Some improbable things are actually getting a lot more likely than they used to be. And of course, this is the iconic, the streepjescode, as people often call it, the progression from, in this case, about 130 years ago to now, with a color coding for how cold or hot the year is compared to the average. And you can with the naked eye, see how rapid this trend is already happening. Now, it may not seem like much, but in this case, I mean, this one doesn't even run until today. It runs until around 2018. At that point, we already had about 2 degrees warming for the Netherlands. It's about 2.3 degrees if you include the last couple of years. And mind you, that's already a lot more than the upper limit that the Paris Agreement set of 1.5 to 2 degrees, right? That's of course a global average temperature rise. We're warming up faster in the Netherlands than the global average. But this pattern in general, this rapid increase is now visible all around the world, wherever you look. And of course that's doing something to the rest of our climate as well. And if you look at the longer term historical record, I don't have a pointer here, sorry. If you look at the longer historical record, that is a really rapid increase in temperature. So that 2 degrees in the Netherlands in just over 100 years is an unprecedentedly rapid increase in temperature. And then if you look on the right-hand side, what you see there is that same increase in temperature. So on the left-hand side, you see it on a much longer time scale of thousands of years, and you see how high that peak is compared to the natural variability. On the right-hand side, you see that same temperature progression over the last 150 years. And you see the 2 colors around it are the modeled climate simulations, where we try to understand what's happening in the climate system. And there are all kinds of ways we can explain all these little ups and downs from year to year. As you could see here, we have warmer and colder years still. You see, in 2011, we had a relatively cooler year. So once in a while, you still get a cooler year. Once in a while, you get a very hot year. And that's all explainable. There's natural variability in the system, and there's a couple of natural drivers in the system, such as solar intensity, big volcanic eruptions that cool the Earth for a while. I'll come back to that in a minute. So there's all kinds of explained modes of variability in that system, but only if we include the increase in greenhouse gases due to the human emissions, primarily the burning of fossil fuels, can we explain this very, very rapid rise. So we are now virtually certain, is the language, the consensus language of all scientists and all governments in the Intergovernmental Panel on Climate Change, that the rapid rise we're seeing is happening, but secondly also that it's due to human activity. And that then brings us to what's facing us now. Because what this is just global temperature. And what's that doing to all kinds of other phenomena around us, things we care about in our daily lives. And that was the question I got on the first day I started as the Director General of KNMI. On the 1st of February, I traveled to Zeeland for the remembrance ceremony of the 1953 floods in the Netherlands, in the southwest of the Netherlands, where around 2,000 people died. And the question was, so did we see that coming in 1953? And secondly, are we now, having constructed the Delta Werke for tens of billions of euros, are we now safe? Will this, can you assure us that this won't happen again? And so I first looked up what KNMI knew about this storm coming. And it's very interesting. You can see here on the left-hand side these beautiful old hand-drawn weather maps, like we're now generating them by computers, running fancy models. At that time, people were primarily using brain power to develop these same weather forecasts that we're now still using, that you get on the news. Hand-drawn maps, and in fact they saw this thing coming several days in advance. They didn't know how bad the consequences would be, but they knew that it was going to be a really big storm and that it would cause a big storm surge. And in fact, the meteorologists that evening pleaded to Hilversum, to the radio stations that would usually shut off at night, please keep the radio on, because we may want to be able to reach people during that emergency. But 11 o'clock at night, they played the Wilhelmus, end of the day, to close off the day's programming, and the radio shut down. And later that night, of course, we all know what happened. All those people, the dikes broke, and all those people lost their lives. So we did see this one coming, we did warn, and we didn't act on the warnings. Looking back even further, there was an engineer at Rijkswaterstaat, the water management agency of the Netherlands, who already warned in 1938 that this risk was higher than we should tolerate, that there was a risk of one of these dikes breaking in an event like this. But of course, then the war happened, and after the war, we were busy rebuilding our country. So we didn't prioritize. What we knew from an engineering perspective was a pretty big risk, actually an intolerably high risk if you would just use rational thought. But we didn't want to know how big it was that we could face. And it was not happening tomorrow, right? I mean, we can postpone that for a while. Let's first rebuild our country, and then we'll take care of that safety issue. Well, we paid a high price. So the question is, where are we now? Could this happen again? And one example I brought to the audience in Zeeland is Storm Ophelia. This is essentially on the left-hand side. You may remember from when there's big storms in the Caribbean, for instance. You see these images, or in Bangladesh, you know, these tropical cyclones, massive, hugely powerful weather phenomena that also in those tropical countries often, you know, kill hundreds of people, massive damages at the coast. United States, of course, Florida, big damages, big concerns, lots of effort to forecast these things right. So we know a lot about these things. We can forecast them. There's early warning systems for them. But we'd never seen them in Europe, right? So this was one that crossed all the way across the Atlantic, survived, because usually they die out if they get to colder waters, and came to Ireland and caused a lot of damage in the north of Ireland and in Scotland especially. So this happened in 2017, and we had never seen something like this before. So our meteorologists and climatologists were asking, should we have expected something like that? And then we looked and we said, well, it's something that we had imagined would be possible in a warmer climate in the future. And we're running these long-term climate scenarios where we keep the greenhouse gases increasing over the whole course of the century, and we generate weather from year to year. And there is a future weather run where in October 2098, we actually did see a storm. You see it there in the middle. A big storm system like Ophelia crossing the Atlantic and heading toward Ireland. So this was in our climate models. It's not a completely impossible, improbable thing. It's an improbable thing, but not an impossible, improbable thing. But we had expected it much, much later. What happened was 2017, and we had seen it in our future weather for October 2098. Now the second question people, of course, asked, okay, so that's heading across the Atlantic. First country it meets is Ireland. So could this ever happen to the Netherlands? So we assimilated that same pattern into our much smaller scale, much more high resolution weather model for the Netherlands. And indeed, it could just as easily have crossed into the channel and come very, very close to the Netherlands. Good news for Zeeland is, in our hydrological modeling together with Deltares, it turns out the Deltawerken would actually have survived most of this. So there would have been inconvenience and some damages. The bigger problem would actually have been around the IJsselmeer. So that's where you know, the early warning systems need to be prepared for scenarios like this. And there is discussion about upgrading of the inner dikes there. But the main message again is, imagine the unimaginable from the perspective of what's already happening today, rather than thinking that this is a faraway future that we can think about as, do we want this future or not, and how much are we going to reduce emissions? We have already changed the climate, and we are facing some of the things that we thought of as for a far away future. And that's then also the example in many cases around the world where we're now doing this math that I mentioned before, this extreme event attribution, where we're looking at specific extreme events that we hadn't anticipated before and asking the question, is climate change to blame? And the biggest example may be that amazing heat wave in the northwestern US and Canada that you may remember from 2 years ago. What you see there on the top left is the big forest fires that also erupted in Canada. And actually we got a record meteorological reading from a measurement station that burned to the ground just a few hours later due to those fires in Canada. So of course, a fascinating meteorological phenomena, a terrible tragedy for humans there, but a reason for our scientists to do the math on this particular one. And the answer is, it was an unlikely event in the current climate. This is not something that they can expect to happen every year. But it's 150 times more likely due to global climate change. And it would have been very unlikely now, but it was almost impossible without climate change. So these are the sort of things where you can start to say, first of all, we need to think about much more dramatic scenarios that can already happen to us today. And secondly, we need to be aware of the fact that the climate has already changed so much that we're now seeing things that just weren't possible before climate change. And a few other examples, of course, the big flooding in Limburg and particularly also Germany and Belgium, where hundreds of people died in the heartland of Europe. Again, an event that is up to 9 times more likely because of climate change. And I could go on and on. Pakistan's floods, climate change already at work. So we can now do the math on these individual events. And of course, this is one that will be close to heart for those of you living in Maastricht while this happened. The Maas River also very high, but the Geul in particular, also in Valkenburg, massive damage. We just escaped casualties in the Netherlands, but it was close. And it was partly because we had done some preparations, but also in our own crisis risk management systems, we have weaknesses that came to the fore during that episode. And there's a lot of attention to this now. Many of my current conversations as KNMI Director General with the senior civil servants and politicians in The Hague are about examples like this. Including the question, what about similar rainfall in other locations? So we're now running these scenarios for if it would have fallen on a slightly different part of Limburg, what would have happened there? Or if it would have fallen over Amsterdam, or if it would have fallen over a part of Groningen, how would the river management systems there have worked out? How long of a lead time would we have had? And then also, very importantly, and I'll come back to that message later, in terms of early warning systems, how far in advance did we see this coming? And what would we have done in the meantime? And are our systems now ready to anticipate also on shorter timescales? So I've given you a couple of examples of some of these massive events, and you may already have heard a hint or two about the sort of things to expect. And therefore you may already anticipate there's a little bit of a trend issue in this question as well. But who would like to guess about the 3 most deadly so-called natural disasters in the Netherlands in the past century? And I'm putting natural between quotation marks because a disaster is never entirely natural. There's always a man-made aspect in terms of where we live and how we live. But you know what I mean by natural disasters, triggered by natural events. The three biggest. 1953, always the first in any of these lectures, and rightly so, because it is also the most deadly. There's 2 others that are in a similar order of magnitude in terms of deadliness. Any guesses? Second hint, they all happened in this century, since 2000. So not in the whole past century, but since 2000. Cold wave? COVID. Yeah, COVID is also very deadly, of course, but that's not in the disaster statistics. It's not called a natural disaster. It's called an epidemic. But you're right. That's a certainly higher order of magnitude even. Heat waves. You got it. You win the prize. 2 heat waves, frankly. 2003 and 2006. 1,500 and 1,000 people killed. Of course, not killed in the same graphical way that you would see people killed in the Ahr Valley with those big floods in Germany. So it doesn't make the headlines in a similar way either. But you see it in the statistics, in the mortality statistics, like the ones we used with COVID as well, where you see these big peaks in the first wave in the spring and the second wave in the fall of that first year of COVID, you may remember. In fact, if you look at the first year of COVID, with a naked eye, you can see the first peak, and you see a little peak, and then you see another big COVID peak. The little peak in the middle is a heat wave in August of that year. So we still see, with the naked eye, those big heat wave mortality peaks. Until 2006, the Netherlands didn't even have a heat wave plan. We didn't have heat wave early warnings in the Netherlands. We didn't have protocols in elderly homes. Elderly people are by far the most vulnerable. There are many very simple things you can do. You know, if a heat wave is forecast right now, I check up on my elderly neighbors and I ask, you know, are you feeling fit? Would you like me to bring you a glass of water? Make sure you drink your 6 glasses of water a day. It all sounds so simple and almost stupid. But apparently, and I don't feel this myself, but if you get older, you don't feel that thirst impulse so strongly anymore if you dry out. You get tired and you've worn out because of the heat. Especially if the nights also get cold, you just don't recover, and then you don't drink enough, and you literally dehydrate, and that's a major driver of the excess mortality that we see in the statistics. So there's sometimes very simple things that we can do if we're only aware. But yet, if KNMI forecasts a heat wave, and especially if we issue a heat wave alarm, like a code orange or a code yellow for heat wave warnings, the usual reaction we get on all the talk shows and on social media are, oh, there you've got those complainers again. Finally, we've got a nice day at the beach in the Netherlands, and there's KNMI warning us about climate change, warning us about disaster risks. Yes, please.
Cold is more deadly than heat.
Is deadly as heat because in the winter you have perhaps 10,000 deaths just of how you call it, griep?
Yeah.
Influenza. Yes. And so that are more death than from heat. And from heat you get sick if you get heat, but influenza is also a kind of sick because of cold.
Yeah, so you're right. There's also mortality due to cold waves, and if there's a really severe cold wave, we also warn for that. It's also factored into the, and we collaborate very closely with RIVM, the public health agency. So it's in their epidemic models also. All those weather factors are in there. Of course, there's other factors as well that determine whether you get an influenza outbreak. And based on those influenza outbreaks, for instance, there are protocols for hospitals and for elderly homes and so that also get activated. So if there are things that you can do, and for instance, we have the influenza vaccination campaigns in the fall, so there are all kinds of things we do about that because we care about that mortality. It also indeed means global warming is not only bad news. There are risks that are getting lower due to global warming. But certainly the heat wave risk, as you could tell in this audience, it's something we're not aware of as a major killer that is now affecting us in the Netherlands. But good question. Interestingly also, it also demonstrates the distributional impacts of the changing climate. And of course that was one reason for me to work in the International Red Cross on these issues for a long time. We've always had the awareness that poorer countries are responsible for much less of the historical emissions of greenhouse gases, yet they suffer the worst consequences, partly because they are in parts of the world that are already closer to the margin of tolerance. So if you're already in a very hot and dry country and it gets even hotter and drier, then you've got a bigger problem than when you're, say, in Canada, and a bit more warmth actually just extends your agricultural season, makes it more comfortable. They also have problems in Canada, by the way, for instance, melting permafrost. But it's a different type of problem than, you know, if you're in a country suffering from desertification already. But we see similar problems like that in the Netherlands. So interestingly, with heat, I once was on the Resilience Advisory Committee for the city of The Hague. And they had joined a global network of 100 cities, collectively scanning their biggest security risks for the coming decades. And on their list were terrorism attacks, cybercrime, but also climate change. And they had already scoped out what sort of things they should be worried about. And that was primarily flooding. They were worried about extreme rainfall and possibly even coastal flooding with sea level rise. So they had invited the fire brigade to check if the pumps were big enough to get the water out of all the basements, or to make sure that highways below what's it called? Sorry? Yeah, so it's the tunnels, but I was looking for the onder het maaiveld. Anyhow, where the water would stay standing if there's lots of excess water. So they would look at it from very much from a city planning and then engineering perspective. It turned out the biggest problem that they were really facing was heat, a much bigger driver of safety and security issues for The Hague than excess water. And then they started looking at where the heat problems really were. And there's a big difference where in the city you are. And it turned out the biggest heat hotspots, if you just look at this, this is a map made by TU Delft of the heat island effect within the city of The Hague. And you see some neighborhoods are much hotter than others. And it turns out the hottest two are the Schildersbuurt and the Laakkwartier, which you may know from the news as the problem areas of The Hague. Lowest socioeconomic indicators, lowest life expectancy, highest morbidity, so all kinds of other diseases that also make you more vulnerable to heat waves. Parts of the population that doesn't have Dutch as their first language, so less susceptible to getting public messages from the authorities about what to do in those cases. So a double social problem in a way, that it's those people being particularly affected. And then the city of The Hague looked at solutions. One of the solutions to deal with heat in the city is to make the city greener, right? A greener city is a cooler city. And that's when one civil servant in the city of The Hague jumped up and said, yeah, we've already got that solution. We have a subsidy program where people in the city can apply for a subsidy to add greenery to their street. You know, you can get a subsidy to plant trees or to get rid of some tiles and create some flowers in your neighborhood. So we have a program for that. Let's see if that's working and if it's addressing this problem. And it turns out the program was indeed generating a flow of subsidies. But the subsidies were all going to those coolest areas, the nice green villa neighborhoods, where people knew how to fill out a subsidy form and where people were interested in a nice green environment around them. Whereas in these dense urban areas, for instance, greenery, especially trees, would create a sense of insecurity at night because it would be darker and people would want, would want safety in their streets. Or it would attract dogs that would shit in the little square in front of my house. I'd rather just have it paved and, keep it clean. So in the end, this became a discussion that was more about how does the community in that neighborhood want to organize its safety? How do people look after each other? In what language can they communicate about these risks to each other? And also, how do you want? What do you want in your neighborhood? And are there other ways that we can meet all these goals? So in the end, it was the director of social affairs rather than the city planners or the fire brigade that were charged to deal with this risk in The Hague. And I think it's a very telling story of also how you need to look at the systemic nature of these risks and also look at it as a much more multidimensional problem than people initially think of. And then just to give you the picture in terms of how fast these things are changing, I really like this figure from the synthesis report of the Intergovernmental Panel on Climate Change. So just to tell you a little bit about that, so this is the science body that advises the world's governments on the state of knowledge on climate change, essentially. And it was already initiated before Rio in 1992 when the global UN Climate Convention was started. Because people already realized at that time that this was going to be a thorny, difficult issue for diplomats to deal with. And already at that time there were thousands of publications, good scientific papers, but difficult to read for a lay audience, with slightly different interpretations of exactly how bad the problem was and how sure we were that humans were indeed contributing and what to expect for the future. And diplomats knew there were going to be differences between countries. For instance, Saudi Arabia would have a very different perspective than Fiji in terms of how big of a problem sea level rise would be and how much we would want to get rid of oil, for instance. So they already anticipated we're going to have different perspectives. And if we're going to have to argue about the science as diplomats, we're definitely going to fail, get to any sort of agreement. So let's ask the scientists to create a summary of all the science for us. And then what we'll do is we'll organize a process to get the best scientists together and to summarize what's already in the science. So they're not going to give us their own opinion. They're not going to do new research. They'll just summarize everything that has already been published in the peer-reviewed literature. They'll put all of that in a big report, do a summary for policymakers, and we, as governments, will come together with a selection of those scientists, and together we will finalize that summary for policymakers. And then we'll all agree that that summary for policymakers is the truth. And then when we negotiate about a potential climate change agreement, for instance, or in that case, they were still thinking about all these environmental conventions in Rio, we will have a sort of a Bible. We'll have the truth to work with to then negotiate about what, from our various perspectives, we think is the right diplomatic solution. So that system is now in its 6th cycle. So the first cycle led to the creation of the convention. Several cycles, only the 5th cycle led to the Paris Agreement. We just completed the 6th cycle, and it has 3 big chunks. One is on the physical climate science, so what's happening in the atmosphere and the oceans, and what do we project for the future. The second, which I was coordinating lead author for, is on impacts and adaptation. So what do we see happening? What risks do emerge to ecosystems and to human systems, but also how can we adapt to them? And the third bracket is about mitigation. How can we reduce the emissions that are causing this problem? And in March, we issued the synthesis report of all of that stuff together. And this is, I think in our Working Group 2 report, we had I think of the order of 20,000. So this is of the order of 100,000 scientific publications summarized. And in this case, all the publications about what's changing in temperature, and then also how that could evolve in the coming century. And what I really like here is how they've put together the generational perspective there. So if you're born in 1950, you were born in a much cooler world than the one that we live in now. But for the future, people that live now are going to face a warmer world almost regardless of what we do on what choices we make on emissions, right? There is a continued warming already built into what we have emitted so far. But what happens toward the end of the century, and what happens to that baby born in 2020, whether it's going to be a somewhat hotter world or an almost intolerably hotter world, that is still for us to decide. So we have faced a massive change already. We've created a massive change already, and we live in a changed world today. But how much more change will generate is still up to us. And this is then, and I won't take you through all the science here. I know you don't have a lot of physical science faculties here in Maastricht, so I'll probably just bore you to death if I unpack this entire figure. But essentially what this shows you on the left-hand, on the vertical axis, the amount of warming that we generate, and on the horizontal axis, the amount of emissions, the cumulative CO2 emissions, how much total CO2 we emit, that we can afford to stay within those limits with a band of uncertainty around it. And essentially what it shows you, if you want to stay in these lower scenarios, the not extremely hot futures, we have only a limited amount of total CO2 that we can emit. And this is where those big headlines come from. We've got 7 years left to turn the tide. Basically, that is how much CO2 emissions at the current rate of using fossil fuels we've got left until we hit these limits where we can no longer stay in those cooler, the cooler side of the future perspective. So this is a time bomb, as Guterres would call it, that is ticking. And every day we keep emitting at the rate we do now, we're using up more of that space. And at some point, we're moving out of the range where we can still stay in these lower scenarios. Now, what does that mean in practice? So this is what you saw here was essentially the Working Group 1 calculations. So this is the physical science side. How much greenhouse gas emissions lead to how much temperature rise? This is how much temperature rise leads to how much risk. And what you see there on the left are those same scenarios, how the climate has already changed. That's the black line. And remember, on one of those first slides I showed you, if you look at a 2,000-year perspective, that black line is an almost straight up horizontal line. So it looks a little bit benign, but it's actually a very rapid rise. But then on the extension of that from 2015 or so onwards, you get a number of different scenarios about how the temperature could evolve in the coming decades. And you can see that in all scenarios, even the lowest one, it's still going to rise for a little while to come. So we haven't yet faced all the consequences that we can expect, even if we completely turn off all fossil fuel use today. In the most optimistic scenarios, we'll still even get a little bit above the 1.5 degrees. That is the bottom, the safety margin that Paris Agreement mentions. So that point we've already passed. But what you can see on the right-hand side is then the accumulated evidence from tens of thousands of scientific publications about what it means in terms of levels of increased risk due to climate change in a couple of big categories that we're concerned about. On the left-hand side, in those 5 brackets, these are called, by the way, the burning embers. That's the scientific term, how everyone knows them. And they've been updated in the past couple of assessment cycles every time. The first on the left is the unique and threatened systems. So these are, for instance, ecosystems that will just disappear at that level of warming. One of the reasons why we're getting into the purple after 1.5 degrees in that bracket on the left. And again, this is 1.5 global temperature rise, right? So in the Netherlands, by that time, we'll already be heading towards 3 degrees temperature rise. But 1.5 global, for instance, means that coral reefs will almost all disappear. So those ecosystems that are, first of all, just beautiful and part of our world, but also are the breeding chambers for many species of fish. And in that sense also for large economic activity for many countries. They also provide coastal protection for many of those low-lying islands. Those systems will disappear. And the purple in particular is a category that means a very high risk in terms of how the warming climate is causing other problems that we see as a risk, but also how much we can still do about it. And in the purple category of risk, there's little we can still do about it. In the yellow and red, it will take increasingly more effort to deal with it, and it will have increasing consequences that we won't like, but there is still some margin to deal with it. In the purple, there's little we can do. So after 1.5, we start losing critical systems, and that's one of the reasons why the IPCC also really advised the Paris Agreement to stay close to that 1.5 limit rather than go to 2 even, let alone go above 2. Second category, extreme weather events. And you can see the grayish bar, the horizontal bar just above 1 degree is where we are right now, right? So in all of these categories, we are already at an increased risk. And in fact, for the extreme events, we're starting to move into the red. And this is partly based on all that evidence from those extreme event attribution studies that I showed you before. We are already seeing a fingerprint of climate change in so many global disasters. The third one is the distribution of impacts. And this is, for instance, the example I mentioned about The Hague, but also the example about North and South, some countries suffering much more than others. The fourth one is a really difficult one. These are the global aggregates impacts. So as a world at large, are we gaining or are we losing? And there are some areas, you mentioned influenza, where global warming is bringing some benefits. And in Canada, as I mentioned, or in Russia, agricultural production is probably going to go up. They'll have some problems, but those countries will be net winners, at least up to 1.5, maybe even 2 degrees of temperature rise. At some point, everyone starts to lose. But of course, also, some are already losing today. So that's the distribution of impacts. If you add them all up, when are we all going to get hurt? And we're getting toward that point where probably as a world collectively we're already losing. The fifth one is maybe even more important. And these are what we're calling in scientific terms large-scale singular events. And these are what people are also calling tipping points. Things in the climate system that we sometimes don't fully understand how fast and how big they're going to get. But if we get them, they're huge. And one example would be the melting of all of the ice on Greenland. 6 meters of sea level rise, if that all goes, and it won't grow back once it's gone. There are also self-reinforcing effects in the system. So for instance, if permafrost starts to melt, and it would release a lot of methane in those areas, frozen gases that are now in the ice that would get released. Methane is a very powerful greenhouse gas itself. So that would speed up the warming, which means more permafrost melting, more methane released, more warming, more permafrost melting, and et cetera, et cetera. You can imagine some of those runaway effects. Another one we're concerned about is the thermohaline circulation in the oceans. So the oceans, as you know, are like a conveyor belt of heat being redistributed around the world. partly driven by temperature differences between the equator and the poles, partly also driven by differences in saltiness. Lots of ice melting at the North Pole means there's a lot of sweet water being melted into the oceans. So there's already differences observable in the Atlantic Ocean, for instance, in terms of that overturning. Now, right now, we actually have a much milder climate than we would otherwise have due to that circulation. So if that shuts off, instead of the warming that we're all concerned about, we could suddenly get a big cooling, and other parts of the world would get a much faster warming than we would have expected. So there's all kinds of non-linear effects captured there. And again, these events, we know we are already at a higher risk of having triggered them, and they may already be starting to happen, and we see a few of them where we're concerned. I'll give you an example. But certainly it's a risk that we would like to avoid. And to give you one example, the Thwaites Glacier is a piece of Antarctica, at the edges of Antarctica. And what you see there is a piece of it breaking off 1,270 square kilometers. So that's not a tiny piece of ice that is just breaking off the tip of a glacier like the famous images you may know from Iceland, for instance. This is huge. And what you see there is a research vessel also studying these things more. We had actually thought of the problem in terms of global sea level rise being Greenland. You know, the Arctic is already melting. Arctic sea ice is retreating. Shipping suddenly becoming possible in terms of benefits, possibly, or also additional risks. But the real problem being in terms of sea level rise, Greenland, because only land ice that melts adds to sea level rise. If sea ice melts, it doesn't have a net effect. Antarctica is much more land ice, but it's also much colder. So the general intuition among scientists was, don't worry about Antarctica. It's so cold, we can take a couple of degrees warming in Antarctica, and still it will be so cold that it will be ice. You know, it's going to only get a problem when it gets close to melting, and it's far from melting. Well, what turns out is at the bottom of some of these glaciers that end up from Antarctica in the sea, we're seeing processes that we hadn't expected in our models. And we're seeing this breaking off happening much faster than we had expected before. So there's stuff happening there we don't quite understand, and that was only in our models for much further away or not in our models at all. So it shows you that and then of course what happens is if at the bottom of the glacier more breaks off, then it means they start sliding into the sea more quickly. And that means a net loss of land ice from Antarctica into the sea, which could mean that some of these global sea level rise scenarios would speed up dramatically with massive consequences also for the Netherlands as a delta. So we're now having scenarios, best guess scenarios of sea level rise that include scenarios of up to say 1 meter in the Netherlands, but also we've got a couple of worst case scenarios that start including these effects, which start adding several meters of sea level rise over the coming centuries with pretty dramatic consequences for the west of the Netherlands. Now, that is the climate change driven story. But a key thing I want to mention is that a lot of what's in these bars, for instance, in this second bar on extreme events, depends a lot on how we manage those extreme events. So part of the reason why we're getting into this red already is that we're pretty poorly prepared for the current weather extreme events in many cities around the world. So many of the densest places on Earth that are actually also growing the most rapidly. You know, 70% of the global population will be living in cities. Many of those cities in developing countries are growing really rapidly as we speak. And in many places we're not prepared for the current climate, let alone how the climate is changing. So we've got big choices to make there in terms of how these risks will evolve over the coming centuries. Here's one example also. I already told you about heat. This is my own town of Utrecht. And you can see this is a cycling experiment where we put heat sensors on cyclists during their commute. And you can see there's parts of the city that are much hotter than others. So you can understand and also then manage that risk. Oh, sorry. Another example, biodiversity loss. So we know that the rising temperatures are going to create a problem for many ecosystems. But there are many other pressures on those ecosystems as well. And how we manage those other pressures will also have a big impact, particularly for a milder, so if we stay below 1.5 degrees, we will still see big ecosystem losses. But if we manage to keep other pressures down, those systems will be able to take a lot more. Similarly, impacts on healthcare. This is actually during COVID, a maternity ward in Uganda that was also hit by a landslide. So like a, adding up of different challenges at the same time. In this case, then depriving people from the healthcare that also protects them from other risks. How you, first of all, organize in this case your protection from these mud flows, whether you have an early warning system to get people out of this hospital in time, but of course also how you then have these facilities in the right places with the right levels of construction standards determines how safe and secure your population is. And then of course some of the places that I used to work in with the Red Cross, where we actually had the biggest concerns, are the places where the data are poorest, but where people are by far the most at risk from the changing climate. And you may know about the current famine going on in the Horn of Africa, Somalia in particular, parts of Ethiopia. Now, they've had 6 consecutive drought seasons. So whether it's climate change, we don't even know for sure, because the long-term data records are missing, the models aren't so good for those regions. But it certainly fits a pattern of that increasingly volatile global climate. The temperature increase also in that region is one thing we're certain of. But the reason it's leading to famine is, of course, that there's also the conflict going on, that markets don't function well, that the government isn't able to care, there's no social safety nets, that even humanitarian organizations cannot always reach those people. Aggravated, actually, last year, to the extent that there's a market prices shot up because of the war in Ukraine and the rising global food prices. And even for the World Food Programme and the Red Cross, it meant with the same amount of money from donors in the north, we could only afford to reach 1/3 of the same people because food prices had tripled. So these sorts of effects are hitting people in those places hardest as well. And then one of the challenges is that the solutions we're trying to find are segmented. So we have a humanitarian system now trying to deal with that famine. We've got a completely separate climate finance system that's trying to, under the Paris Agreement, transfer money from rich northern countries to poorer southern countries to deal with climate risks. We had a pandemic going on at the same time, yet another policy approach to trying to deal with it, whereas in many cases it's actually the adding up of those different risks that is creating the biggest problems. And I would say in reverse, we haven't made the most of the opportunities with the shocks that we've had. With COVID, in the social safety net programs we've had around the world, we've spent billions and billions and billions in each individual country. I think in the Netherlands it was, does anyone know the number? I think it's tens of billions of dollars just on social safety nets in the Netherlands. Have we used that to turn the corner on any of those other risk categories in the Netherlands? Similarly, right now, you could ask the question with the Ukraine energy crisis. In a way, the biggest opportunity to also contribute to meeting the Paris goals. Are we making the most of that? Well, to a large extent. We are also subsidizing fossil fuels right now to keep it affordable for people. Is that a smart thing to do in light of all the different shocks coming our way? So, if you look at all of this, where does that take us in terms of what's needed? And of course, what then happens is that this annual meeting, in this case, convened tens of thousands of people in a place at the edge of the Red Sea, but actually in the desert in Egypt. Very convincingly, during the first couple of days, there were so many delegates there was not enough to eat and to drink, which was a nice symbolic gesture for what they needed to negotiate. And you get into these settings, or sometimes into these settings, into the last nights, trying to resolve these problems. And it's hard work, but the nature of this is, I mean, we can joke about it, but it's also, it's serious business. It's the only process we have to deal with something that, especially on the mitigation side, so on the reducing emission side, is a prisoner's dilemma to some extent. So the question is, how much do we do on this first front of mitigation? Now, part of the problem is that we've got a historic reality that's different from the current reality. And if I give these lectures, many people are asking, so why would I change my behavior if in India they're turning up 3-4 power plants a week with coal-fired electricity production that is adding so much to this global problem? What I do doesn't make a difference. Well, then I often ask, well, look at the per capita emissions right now in India compared to the per capita emissions in the Netherlands, and you'll see that the Netherlands is still way higher than India. But secondly, if you look at our historical emissions, we've got massively more on our shoulders already. So of course it is upon us to lead the way. Secondly, if we want to convince India, so we currently have a 2050 target for carbon neutrality in the European Union. China has a target for 2060. India has a target for 2070. 3 years ago they didn't have a target, so at least they have a target. If we want India to come forward and China to come forward so that collectively as a world we're at carbon neutrality in 2050, which we need to get to that 1.5 degrees. If we want that, clearly as a European Union we're going to have to be faster than 2050. Yet everyone's already arguing that the current packages proposed in the European Union are not fast enough. So there is a dichotomy there. The second thing with this field of mitigation is that it's in the diplomacy coupled to a second, I'll just let me give you this first in terms of where we are on mitigation. After the last round of negotiations in Sharm el-Sheikh, this is the summary of the chairman, a conservative politician, mind you, who was the chairman of the previous round of negotiations in Glasgow. As you remember, that was the first sort of big summit where we looked at whether we were headed in the right way after we had closed that Paris deal in 2015. And after the summit in Sharm el-Sheikh, he summarized the situation as follows. Emissions peaking before 2025, as the science tells us is necessary, not in this text. Essentially, science very clearly tells you if we do not peak global emissions before 2025, we're never going to reach global temperature, we're never going to keep global temperature rise from below 1.5. Clear follow through on the phase down of coal. Coal, the most polluting energy source we have at the moment, not in this text. A clear commitment to phase out all fossil fuels. So over time, getting rid of them all, not in this text. And the energy text weakened in the final minutes, he might add, because there was a stronger text on the table, diplomats had worked hard, but then a couple of countries changed that text at the last moment. Friends, I said in Glasgow that the pulse of 1.5 degrees was weak. Unfortunately, it remains on life support. So it means that many of those risks I showed you before are coming our way, whether we like it or not. Many scientists that you would ask are saying 1.5 is going to come, in a couple of years. And the question is, how much worse will it get thereafter? Now, I'm an optimist by nature, and I think there's two important messages from this which take me to the second branch of what we need to do, adaptation. We have no choice but to adapt to what's happening. And in two ways. First of all, managing our own risk. But secondly, also in the Paris Agreement, there are three pillars. There is a pillar of making sure we do everything we need on the emission side to stay below 1.5 degrees, but also dealing with what's already changed and what will continue to change through adaptation. And thirdly, a solidarity element of it with a financial transfer from the richer countries to the poorer countries to help them do that. And countries like India are not just saying you need to lead the way on emissions, they're also saying you need to foot part of the bill of us dealing with the mess that you've created. Help us adapt and help us also increasingly, and that's the next branch, deal with loss and damage. And especially Pakistan, of course, which had just been flooded a few months before this global summit, was asking for compensation for loss and damage. There was a red line in the negotiations for a long time. Countries, including the Netherlands, were saying we're not prepared to discuss this at all, partly because it would create a legal precedent of that sort of transfer for losses and damages, of which we have no idea how to calculate them, but also how big they might get. As part of the deal in Sharm el-Sheikh, there was a breakthrough that there is a recognition that this loss and damage is already happening and that there will be a fund to compensate part of these damages. How much is going to be in there and who is going to get how much for what types of disasters, still to be negotiated. It's going to be a painful and long negotiating road. But it's there as a reality today. And then one of the questions becomes, what can we do? If we are starting to compensate, if we're starting to accept that this reality is there, how can we put the money that we would put into a fund to use in the best possible way? And that's where a new agenda has emerged to use money more efficiently, also just before disasters happen rather than only after. And this has been one of the big frustrations we had in the humanitarian system for a long time. We get very generous donations in the International Red Cross, for instance, after a big disaster hits the front page of the newspapers, or when a minister gets asked in Parliament, are you helping those poor people in country X, Y, or Z? But in fact, the same euro can go so much further if you spend it a couple of days or a couple of weeks or a couple of months earlier. So we have now created systematic, so-called forecast-based financing mechanisms that start disbursing some of that money based on forecasts ahead of the event. Now, if you can use some of the money under these new mechanisms to enable some of those funding mechanisms, you can actually reduce the costs of these disasters and get a double win. Secondly, in order to do this, you need to create the risk information. Who are the most vulnerable folks? What sort of risk can you mitigate at the short term? That also gives you the information of where are your highest risks to reduce risks over the longer term. So it also feeds that longer term adaptation agenda. And this is one of the core pillars now of one of the building blocks for that loss and damage agenda that UN Secretary General Guterres has coined. And you already used his quote about the highway to hell. He had another one, which was that the IPCC report was a survival guide in this changing climate. And I like that sort of hopeful, optimistic way. We're getting some tools, there's stuff we can do. And this early warning systems for all initiative that he launched is an example of that. Investing in things that we know work, that we don't have all around the world. There are many countries not covered. There are also many countries that still have work to do, including the Netherlands. So strengthening those is a key commitment, which is a completely new branch of work on climate change from where we were 10 years ago. In the Netherlands, we have created an early warning center, so the KNMI is working in a very different mode than 10 years ago, partly enhancing the quality of our classical hazard forecasting, so no longer just providing, for instance, the warnings at a provincial level, but in a few years we'll be providing them at postcode level, so much more detailed, longer in advance, but also much more in chains of users. So we're working, for instance, with the water boards, the waterschappen, or the safety regions, the veiligheidsregio's, to integrate not just the number of the sort of the millimeters of rainfall, for instance, that will fall, but to try and project how much flooding will that result in. And what type of damage do you then need to expect? And what do you need to do in order to prevent that damage? Now, of course, that's not something KNMI can do on its own. That's just like that forecast-based financing example that I showed you in Bangladesh. Also here, that's a chain with the water boards. If we issue a warning for certain millimeters of rainfall, they turn up their pumps or they open their sluices. And then once they've turned up the pumps as much as they can and opened all the sluices, and with the millimeters of rainfall that we're forecasting, there's still a problem, then we need to hear back from them that that's a reason for a code orange or a code red warning in the particular areas that might get flooded, rather than for the entire province, where many of you might sometimes rightly complain that we're issuing a code orange, whereas there's only a problem in a part of the province. So all these developments apply just as well to the Netherlands as they apply elsewhere, and there's a high political pressure. The staatssecretaris, the deputy minister, responsible for KNMI in the cabinet is Viviane Heijnen, who you may know as a wethouder here in the city of Maastricht before. So she knows firsthand that we are once in a while getting surprised and that our information flow can still be improved. A final one, and one that I am certainly not presenting to you as a solution, but as something I think you should be aware of, that it's on the table, and to me is partly also a reason to be even more concerned than I really was about the science that I've been presenting to you, is geoengineering. And geoengineering is an umbrella term that actually should be split in two. And one branch is a lot less concerning from a risk perspective than the other. The one is essentially artificially taking CO2 out of the atmosphere, carbon dioxide removal. Frankly, the optimistic IPCC scenarios I showed you all need a fair amount of this. And we cannot count on huge amount of it because it's not proven that we can do it on a large scale. But we'll need some of it, and we should invest in those technologies. If you remove CO2 from the atmosphere, you're basically turning back the clock on the amount of warning that we get. So you get a sort of a linear return to a safer level of greenhouse gases and a safer temperature level. The other side is called solar radiation modification. And this is essentially artificial cooling, turning on your own thermostat directly on the temperature of the Earth. And I thought this was, and there's all kinds of possible ways of doing it, space mirrors, cloud seeding, reflective aerosols. I thought when I first heard about this 15 years ago or so, that's just technology dreams, people dreaming this up, never gonna happen, way too expensive, way too complicated. But that's where I was really wrong. We know it works, and the precedent are volcanic eruptions. So Mount Pinatubo, for instance, in the early 1990s, cooled the global climate for a year and a half, and actually you even see it in global sea level trends that dip for a while after Mount Pinatubo because the global temperature cooled. And that is one big volcano, a really big one, but still, it's the sort of thing that, you know, we can emit similar stuff into the stratosphere. You need to put it high up in the atmosphere, in very stable layers where it stays for a long time. Then it does provide you with a little bit of a shield for the sunlight that actually does cool the planet. And you can do the math on how many planes or rockets you need to get that stuff up into the higher atmosphere. And it turns out per degree cooling, it's cheaper than the shift to renewable energy to get the same amount of cooling compared to the warming track we're on. Now, of course, you need to keep doing it. And if you stop doing it, you get double the warming that you've accumulated in the meantime. It also doesn't stop the acidification of the ocean. Ocean is getting more sour due to the increasing CO2 concentration. So there's all kinds of other things it doesn't stop. It will also generate other effects. So this is not a linear turning back the clock. This will also start changing precipitation patterns. So there are all kinds of reasons why you should be concerned about it, but not the fact that it's too complicated or that it's too pricey. So there is serious work happening on these technologies right now. A private company, launched a balloon into the stratosphere in Mexico recently and launched some of these aerosols in the stratosphere. Mexico was not pleased. It was a private company, it didn't have permission, and Mexico now has a ban on these technologies. But it shows you also how fast it's moving. So some companies are proposing that, you know these offset schemes where, you know, if you fly to Barcelona for the weekend, you can pay for someone to plant a tree somewhere to compensate for your emissions. Well, some of these companies are now saying, instead of you paying for me planting a tree for you, which over time, you know, the tree needs to grow and then it takes the CO2 out of the atmosphere, you can also pay me and I'll let a balloon up into the stratosphere and I'll compensate by releasing aerosols in the stratosphere to compensate for the warming that you generate with your flight. So these sorts of schemes are happening. I'm not saying that I'm warning that I don't think this is the solution, but I think it is something that is happening faster and we need to be discussing how we're going to govern this, because that's primarily the problem. Who is going to control that thermostat of the Earth if we ever want to use it, and who's going to deal with the side consequences that might generate? The fact that we're even having that discussion, this was actually triggered by my own PhD supervisor 20 years ago, Paul Crutzen. He was actually one of the 3 Nobel Prize winners for the discovery of the hole in the ozone layer. He said at some point we may need to think about these technologies because I don't trust that we can get the greenhouse gas mitigation, so the reduction of emissions, under control quickly enough. And if we get into one of these runaway climate scenarios, we may want an emergency valve and some sort of stopgap measure to be able to cool the climate quickly. And then we want to have done the research. Whether that's the right thing to do ethically, and indeed then who needs to do the research and who needs to control it, I think is an interesting topic for philosophical as well as scientific debate. But the fact that we're now considering it so seriously and that there's so many different actors coming to this table is, I think, a sign of how seriously we're also off track in terms of reducing emissions and how much effort it will be to deal with